In this problem, we're given two transformers. We know the load voltage and we know the power that the load consumes. Here it's 2 kilowatts, all resistive. We know the turns ratio of the transformers, and we are asked to find the source voltage. The only complication to this particular problem is R1, which represents the high voltage wire between the two transformers. Before we start, let's quickly review the rules. You recall the turns ratio is the turns of the primary over the turns of the secondary, and that's equal to the voltage ratio, which is the voltage of the primary divided by the voltage of the secondary. And we have the current ratio, and you'll notice that those are flipped. So there you have the current of the secondary divided by the current of the primary. We also have power. Here we see that the power in the primary is equal to the power in the secondary. And we're using the vector form here, S, for complex power. Keep in mind, all of this is applicable only to the ideal transformer. To work this particular problem, we start on the right side and we make a few statements. We know that the voltage on the secondary is 277 volts. We know that the power on the secondary of T2 is 2 kW. We then move one step to the left and we see that the voltage on the primary of T2 is 277 times 5. One way to look at this is to say you have a low voltage side and a high voltage side. So the 277 volts is on the low voltage side, and then we multiply that by 5 to get the high voltage, which is 1,385. In the ideal transformer, power in is equal to power out, so we can just carry our 2 kW across the transformer, which brings us now to the secondary of T1. But before we can do that, we have to calculate the voltage loss across R1. For that, we need to know the current, which is 2 kW divided by 1,385 volts, which is about 1.44 amps. We can do a little bit of KVL thinking here. We can say that the voltage on the secondary of T1 is that 1385 plus 50 times 1.44 amps. Again, that's this resistor here, where the voltage on that resistor is a current times a resistance, which is equal to 1.44 times 50. When we solve for that, we see it's 1,457 volts. And finally, we can go to the source, where we do a simple division by 5 to derive 291 volts. To recap this problem, we worked it from right to left. We had 277 volts on the secondary of T2. We had 1,385 on the primary of T2. We had a 72 volt drop across R1. We used KVL to see that the secondary of T1 has a voltage of 1,457. And then we divide by 5 to see that the primary of T1 has 291 volts.